Hello. So this video is going to cover the review and preview problems found in lesson 111 of the CPM Algebra 2 curriculum. It is recommended that you attempt these problems prior to watching this video. So if you have not yet attempted these problems, please stop this video and go try the problems yourself. As you work through these problems, it is recommended that you pause the video. If you have not yet done that problem, do it first. If you have done it and you feel really good about that problem, then feel free to fast forward and look and review problems that you've already attempted or you need extra support with. Okay, so first problem in this lesson is problem 1-3. Is talking about keeping a notebook. So this isn't really a homework problem as it is more of a organizational tool. So it's really important you stay organized in Algebra 2 as you'll have lots of notes, lots of test quizzing, things you want to understand and be able to refer to. So the curriculum really suggests that you get a sturdy 3-ring binder for just this course, not to use it for other courses. And you should divide it into these selected 5 areas. However, you should always refer or ask your teacher. They may have a specific way they want you to keep this notebook. You should put in your notebook how to return it to you should you lose it. Again, you're going to be wanting to refer to these notes, the core problems, the assessments, any in-class worksheets, and your homework problems a lot. Sometimes this curriculum will refer back to problems you've done in the past, so it's really important you don't throw anything away. Okay, so the first problem is problem 1-4. So it says find f of 3 means to find the output of a function f of x for an input of x equals 3. For the function f of x equals 1 over x minus 2, find each of the following values. So for the first problem, we want to find f of 4. This means find the output of the function when x equals 4. So when f of 4, in the function given, we're going to replace every x with the value 4. So it's 1 over x, so we put a 4 in place of it, minus 2. So we get 1 over 4 minus 2 is a half. So f of 4 is 1/2. Part B, find x when f of x is 1. This means find the input that gives you an output of 1. So what we want to do is you want to let the rule f of x equals, which is 1 over x minus 2, we want to make that equal 1 and then solve it to find out what that is. You may be able to look at this and tell me what it is right now, but let's go through the algebraic process. So to solve this equation, since the x is on the bottom, we're going to take both sides of the equation and multiply it by the denominator. That's how we get rid of fractions in equations. So the x minus 2's cancel on the left, leaving me with 1. On the right, we take 1 times x minus 2, gives you x minus 2. And then we're going to add this 2 on the right to the left. So 1 plus 2 is 3. So x is 3. That means that when I take f of 3, that should give me 1. Okay, problem 1-5. Before you do this problem, you should have looked at the previous problem on the lesson 111 core problems video that goes over this stacked function machine idea. So if you haven't watched that video and done that problem, it's recommended you stop the video now, you go back and you look at that problem. Okay, so we have two functions, g and h, and Angelica wants to put them in order so that the output of the first machine. So I'm going to draw kind of a rough sketch of these machines. So something like this. Here's one machine, and that output becomes the input of the other machine. So crude drawing here. So she wants to plug in 6 for each problem. And she wants a final output in the first problem of 5. So to think about this, I do not feel like I can get a 5 if I put h of x first. I don't know if there's a way to make that happen. So I'm going to actually put I don't want h of x to be last. I don't know if a 5 can get out. So I'm going to let h of x be first. And then I think if I take h of x and put g of x in after it, I think that's what that'll work. So let's try this out. H of x, when x is 6, I get 6 squared is 36. 36 minus 6 is 30. I'll take 30 and have that become the input of g of x. 30 minus 5 is 25, the square root of which is 5. So that seems to work. So h of x, then g of x is the order I should put them in. Now it says, is it possible for her to get a final output of -5? If so, show how she could do that and not explain why not. Well, there's only two machines, two functions, so I can only reverse the order. So let's see if I reverse it, if that works. Let's start with g of x first. Let's see what g of 6 is. So g of 6 is going to give me 6 minus 5 in the square root. And that's going to give me 1. So that's going to become what I plug into f of x. So f of 1 equals 1 squared minus 6. Well, 1 squared is 1. 1 minus 6 is -5. So that works out. So it looks like if I go g of x, then f of x, that should work out for problem 1.5. Okay, on 1.6, it says an average school bus holds 45 people. Sketch a graph showing the relationship between the number of students who need bus transportation and the number of buses required. Be sure to label the axes. So in this case, we need to understand what our independent and dependent variables are. So what's going to determine what? So our values are the number of students who need bus transportation and the number of buses required. So does the number of students determine how many buses are needed or vice versa? I'm pretty certain how many students I need to transport will determine how many buses I need. So since buses are determined by number of students, the dependent variable is the number of buses. And the dependent variable is number of students. And so independent is x. So we need to put down here number of students. And up here, we're going to put number of buses. Okay, so we know that when there's 0 students, we need 0 buses. That's a filled in dot right here. Now, each one is going to be 45. So we go, because it's 45 people per bus. I'm going to go 45. Every other mark is going to be 90 kids. So we know 0 to 45 will be 1 bus. So we put an empty dot at 0, a full dot at 1, and that's going to be a bar. And then when I go 45 to 90, I need 2 buses. 90 to 3, 135, 3. I just keep doing that every time I increase by 45. So notice there's no connecting the dots. It kind of makes a step situation. So we have to put a filled in dot underneath of empty dot because that passes the vertical line test. So that would be, this is called a step graph. It becomes very important later on, especially in pre-calc, but you kind of want to get an idea of how do you create these. I do not connect the dots because I can't have half a bus. It doesn't make any sense. That's why they're a series of bars, line segments, and not a line. Okay, so number 7. This really talks about graphing and the requirements of graphing. And so we're going to always use graph paper when you ask to graph something. I have a coordinate plane over here. You're going to label key points. We'll talk about what those are briefly, and we'll just get into that more in a later lesson. We're going to scale axes appropriately. So mine are scaled by ones, but you may scale them differently depending on the situation. And we're going to plot points as accurately as possible. So on a separate set of axes, graph each of these equations, meaning that each graph has been done on a separate graph plane, not the same one. And if you do not remember any shortcuts for graphing these, you can always make a table. So this is a line. So from Algebra 1 geometry, you should know this is a line. It's in slope-intercept form. Mx plus b. So to graph something in slope-intercept form, we're going to first graph, so not graph, sorry. We're going to plot the y-intercept, which is 0b. In this case, b is 7, so we're going to plot a point at 0, 7. And the second one is to apply the slope from the y-intercept. So the slope is -2, so we'll do that. So -2 should be thought of as -2 over 1 or 2 over -1. So remember, I can either go up and right. Sorry, not right. It's a negative slope, so I either go up and to the left or down and to the right. So if I want x to be negative, I would go down and then right. So I'm going to go down 2, right 1. And I'm going to plot that as many times as I care to plot it. I like to plot until I can't plot anymore, because more points more accurate, or go up 2, right 1. And then you connect these with a ruler. So you should draw this with a ruler on your own, but that's how you graph a line. Plot points, plot intercept, apply slope, and then connect dots with a ruler or straight edge. Side of a protractor works just great. Okay, so let's try the next one. This is also in slope-intercept form. So we're going to plot the y value, the y-intercept first at +1. We got 3/5, so 3/5 can be also thought of as -3 over -5. So either you can go up and to the right, or I can go down and to the left from the y-intercept. So I'm going to go up first, up 3 over 5, up 3 over 5. So 1, 2, 3, 4, 5. Or I'm going to go down 3, left 5. Whoops. 1, 2, 3, 1, 2, 3, 4, 5. Or down 3, left 5. Up. Sometimes this does it, down 3, left 5. I might connect the dots with my ruler or straight edge. Now, if you do this and you miss a point, I always say make the dots bigger. Okay, next one. Okay, so this is a standard form equation. So there's two ways to do this one. I can either find the intercepts or write it in slope-intercept form. So most of us would probably write it in slope-intercept form. So that means to solve it for y. So to do that, I'm going to subtract the 3x over. So I get 2y equals -3x plus 6. Then I'm going to divide everything by 2. So 2y divided by 2 is y. -3x divided by 2 is -3 halves times x. 6 divided by 2 is 3. This is my slope-intercept form. So I plot the y-intercept at 3. Then I can go down 3, right 2, because it's negative. 2, 3, 1, 2, 1, 2, 3, 1, 2. Yeah. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I can go up 3, left 2. Up 3, left 2. All right, and there's my line. Oops, I was doing good there for a second. Okay. Always make sure your arrows are outside the coordinate plane when you graph these. Okay. Last graph, x squared. Now this is a parabola, so let's make a table. So whenever I graph new graphs, I like to use these values for x, and I just like to evaluate them, generate points, and graph them. So if you're going to graph these, I start with these points here. Let's take -3 and plug it in. So when x is -3, I get +9. I'm going to start plotting points as I calculate them. So 3 9's here. -2 squared is 4, so -2, 4. -1 gives me 1, so -1, 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So then I connect these dots. So with these graphs, you curve through the lowest point. So you want to make a U. And again, just like the lines, you want to make sure that your arrows are outside the coordinate plane. Right. Okay, 1-8. The graph for part D of problem 1-7 is different from the other 3 graphs. Explain how the graph is different than the other 3. Well, it was the only one that was not a line. So the graph did not make a line. Okay? That is, the graph is non-linear. It's a kind of a big vocab word there, as it'll mean more later. B, what is the equation? What in the equation part D makes this graph different? Well, it's the only graph that had an exponent. So the exponent of 2 next to the x. So no other variables in the first 3 had an exponent. And what is a graph called? Well, I kind of said it when I did the problem. It's called a parabola, not a parabola, a parabola. Okay, so 119, write down everything we know about the equation y equals mx plus b. We just talked about it when we graphed those 3 graphs in problem 1-7. You should include what this general equation represents, as well as what each of the different letters represents. So y equals mx plus b, that is the slope, intercept, form of a linear function. So we know that m is the slope of the line. We know b is the y-intercept, or the point 0b on the graph. We know that when we take x and y form a point, and that represents a point on the line. Now lines are made up of infinitely many points, but any xy pair that makes that equation true will represent a point that exists on that line. So I hope this video was useful and helpful to you in your understanding of the concepts in this problem set. If you did find this video useful or helpful, please let me know by liking this video and subscribing to my channel. Thanks for your time.